Okay, the articles are available with us, but we cannot directly use these articles for clustering. The reason being, the clustering algorithms doesn't understand string inputs. We need to find a way to convert these string inputs into a meaningful representation. To do that, we are going to use an algorithm called TF-IDF vectorization. TF-IDF is a popular vectorization scheme which takes the collection of documents and converts into matrix. For example, TF stands for term frequency, which is nothing but how many times the word has appeared in a document, and IDF stands for inverse document frequency, which is nothing but how rare the word has occurred in the entire collection. On a whole, TF-IDF is very helpful to identify the words which are unique and which are span across multiple documents. Let's go and do the implementation. We are going to import the TF-IDF vectorizer from sklearn. From sklearn.featureextraction.text, I'm going to import TF-IDF vectorizer. So my vectorizer would be TF-IDF vectorizer. There are a couple of parameters that we can add to TF-IDF vectorizer, which is nothing but max df and min df and stop words. Max df, when we set max df to 0.5, it means we are ignoring terms which are very frequent and very frequently occurring across the documents. So for example, if a word has occurred more than 50% of documents, we are going to ignore it. And if a word occurs less than 5 is a term here, if a word has occurred less than 5 times in the entire collection, we are going to ignore it. And TF-IDF vectorizer as such has an argument called stop words, which basically ignores the stop words while vectorizing. So let's go ahead and initialize this. Now let's directly go and do the fit transform. Fit transform is the method which converts your string input into matrix. So here we have the articles. We have to pass in the articles, and let me store this as articles TF-IDF. Dot shape. We had the list of articles in a string format. Now we are converting this string input into matrix. Here it is. We can see it took around 4 seconds to convert 10,000 documents, and look at the result matrix. This is where we have a problem. The result matrix is almost 10,000 cross 31280, which is really sparse matrix. With this sparse matrix, if we run a document clustering algorithm, the algorithm might be very slow or maybe very inefficient. We have to overcome this problem. There are multiple ways to overcome this. Let's think about it. Before we go ahead and solve this problem, let's try to understand the root cause of it. Let's randomly pick an article, say article number 10, and split it into words, and find the length of it. (1372). As we can see, the article number 10 contains more than 1300 words. We have picked a corpus of 10,000 articles. When we feed lot of words into TF-IDF vectorizer, the vectorizer is creating a sparse matrix for us. But let's revisit our objective once again. We have collection of wiki articles and we have to group them into a meaningful fashion. So for example, if our objective is to group articles into sports, there will be 50 or 100 words with which we can easily identify whether this particular article belongs to sports category or not, right? So for example, when we encounter the words like play, player, championship, we can easily associate it with sports. But how can we find the keywords which are related to one particular category? So this is where we can use the TF-IDF, the technique itself. TF-IDF creates a matrix with the words and its importance. What if we can, take the same article number 10, but instead of having 1372 words, what if we can restrict it to 50 words which are important to this particular article? Extracting keyword is a tricky part. To make it easy, I am going to break it into 5 different steps. Okay. So the first step is to find the feature names. Feature names equals the vectorizer. This is the TF-ID of vectorizer, and we are going to use the method get feature names out, and I am going to print the feature names. Okay, so feature names is the list of all the words which is available in our corpus. So for instance, if I randomly take an index 2, 3, 4, 5 and run the feature name, the feature name of 2, 3, 4, 5 is adversary. So the word adversary is mapped to number 2, 3, 4, 5. Similarly, we have feature names for all the words in our article. Okay. Now, since we are interested to fetch 50 or 100 important keywords for each of the article, right? Let's loop through all the articles. For doc index in range of length of articles, right? So it will loop from 0 to length, right? So what we are going to do is to find the feature index. The feature index is nothing but the number, like for example 2, 3, 4, 5, right? So for each article we will have an index and the importance of that particular index available as a TF-ID vector. Okay, so what we are going to do is feature index will be, okay, we have the TF-ID vector, and I am going to select only one particular article, right? So for instance, let's add a break statement here so that we can print and see. For instance, when the doc index is 0, that is for the first article, we are going to take the vector and for the first article and select all the columns. Okay, let me print the feature index. So here you can see this is article number 0 and 6657 is nothing but a feature ID, and if we go and query out feature names of 6657, we can find the word. So the word CT is mapped to 6657, right? And this is nothing but the importance of CT, the word CT in this particular article, right? If you think, we are very much interested on extracting top keywords. Okay, so for instance, let me set the number of keywords that we are interested in to 50. Okay, so from each article we are going to select only 50 words. Okay, 50 top words, right? So from this, what I am going to do is to safely ignore the ones which has zero importance. For instance, if there are words which are having zero importance, we don't even have to consider that, right? And I am going to fetch all the feature IDs. So let me print the feature index again. Now we can see we have the list of feature IDs which has non-zero importance. Okay. Now then, once we have the feature ID, what we can do is we can go ahead and derive the score for this particular feature IDs. So find the score for feature index. Okay. To find the score, for example, I am going to name it as TF-IDF score. Okay. What I am going to do is to create, let's loop through this feature IDs, right? So for each feature ID, I am going back to my TF-IDF vector and finding for this particular doc index, for this particular feature index, what is my importance. So for example, what it basically does is if you take 6657, it goes to article TF-IDF vector, and we are selecting the first vector, which is 0, which has a very sparse matrix, right? In 0 we are going to select only 6657, okay, which gives the importance of the word city, right? So what we have done, in the first step we have derived all the feature index. In the second step we are deriving the score of this particular index. Okay, let me print TF-IDF score so that we can know what is happening. Now for each word in feature index, here are the scores. But as you see, now we have feature index in a list and TF-IDF score, I mean the IDF score in a list. So what we can do is we can zip it as one single tuple. Okay, so to do that I'm going to use zip method. Okay, and I'm going to add a feature index here. Right, now the TF-IDF score will be a zip object. So in zip objects we have two items, one is our feature index, another one is our score. So as we know, we are interested to fetch only k keywords, here 50 keywords, right? So let's go ahead and sort these scores. Okay, sort these scores. How we are going to sort? Now in our left we have the feature index and in right we have the importance. We are going to sort it based on importance, right? So my sorted TF-IDF score would be sorted of TF-IDF scores, right? My key will be lambda x of 1. I am sorting based on values, right? Here the values are the importance, right? Followed by a reverse keyword. Why reverse equal to true? Because we have to sort with the words which are having higher importance, right? So let's print the sorted TF-IDF score. Now we can see for the same article we had derived words with higher importance, right? 0.57 comes first and 4089 is the feature index for which we have 0.44, right? So what we are going to do, as we have sorted all these indices, we are going to loop through this array, take out all these feature indices and find out the corresponding words. Okay, so let's write a list comprehension, right? So I'm going to write for, I have feature index and a score, right, in sorted TF-IDF scores. I'm not going to do it for the entire array. I'm just interested till our num keywords, which is nothing but top 50, just 50 words. So I'm going to take only 50 items since we have already sorted. I'm going to iterate it and find the value of I, right? So this will be feature index, right? Let's print this, right? Now these are the top feature indices. Here we have the feature indices, right? Instead of feature index, we need to have feature words, right? To have the feature words, what we are going to do is to have feature names of I, right? Feature names is kind of a map, right? So feature names contains the words, feature indices contains numbers, right? Now let me print. As we can see, we have all the important words, right? So what I'm going to do is to add a join here, right? Dot join all these words together with a space. So my top keywords would be like this, right? Let me print the top keywords, right? Now the same article which was long, right? We extracted top 50 keywords from the article, and since we have the break statement, it is running only for once. Let me remove the break statement and add a TQDM here, right? So let's go ahead and do it for all the articles. From TQDM, import TQDM, right? Let's run it for all the articles. Now for each article, it is deriving the top keywords, right? But one thing that we missed here is we have to, once we find the top keywords, we have to append it back to a list, right? So let's just have a list keywords and append it to it, append our top keywords to it. So keywords dot append of top keywords, right? So let me interrupt and run it again, right? So run it again, yeah. Okay, so once this process is done, we can clearly see that we have, instead of having each article with 10,000 or 20,000 words, we would have effectively extracted top 50 words from the article, and when we provide this input to any clustering algorithm, it's much more faster and much more effective as well. Let's wait for this execution to be done. Yes, it's over. Let's go ahead and print the keywords. As we can see, it's a list of all the articles, right? So let's do one thing. Let's have a data frame, import pandas as PD, right? df equals pd.data frame of, I'm going to create a list. So I'm going to have the article, it's the original article, which is nothing but our list of articles, and followed by keywords, which is nothing but the keywords which we derived, right? Let's run this and do df.head. Here we have the list of all the articles along with the keywords, right? So the articles might be very long, and these keywords are just 50 top keywords of each of these articles.